Okay, so you've got this cool electronic project in mind. You've got your breadboard, resistors, LEDs, maybe even a microcontroller. Everything's ready to go, but then you hit a snag. You need to control a high-power device like a motor or a solenoid. What do? You reach for a relay, right? But when exactly is the right time to use one? That's what we're going to figure out today. Let's start with the basics. What is a relay? Essentially, it's an electronic switch controlled by a low-power signal. This low-power signal can then activate a switch that can handle much higher voltages and currents. Think of it as a tiny remote control for a big, powerful machine. Now, you might be wondering, why not just use a transistor to control the high-power device directly? Well, transistors can handle some power, but when you're dealing with loads that draw a significant amount of current, they can overheat and burn out. Relays, on the other hand, physically separate the control circuit from the power circuit, making them much more robust. So, when should you actually use a relay? Scenario 1, high current loads. This is the most obvious one. If you're trying to control a device that draws a lot of current, like a motor, solenoid, or even a powerful LED array, a relay is your go-to choice. Transistors simply can't handle the load. Scenario 2, isolating circuits. Sometimes, you need to isolate two circuits from each other. Maybe you're working with different voltage levels, or you're concerned about ground loops. A relay can provide that isolation, preventing unwanted interactions between the circuits. Scenario 3, switching AC loads. Transistors are primarily used for DC circuits. If you need to switch an AC load, like a light bulb or a fan, a relay is the way to go. Scenario 4, controlling multiple devices. If you need to control multiple devices with a single control signal, a relay can help. You can use a single low-power signal to activate multiple relays, each controlling a different device. Scenario 5, safety. In some cases, using a relay can improve safety. For example, if you're working with high voltages, a relay can isolate the control circuit from the high voltage circuit, reducing the risk of electric shock. Okay, so we've covered the whens, but how about the hows? There are different types of relays out there, each with its own characteristics. Electromagnetic relays, these are the most common type of relay, using an electromagnetic coil to activate a mechanical switch. They're relatively inexpensive and reliable. Solid-state relays, these use semiconductor devices instead of mechanical contacts. They're faster, more reliable, and have a longer lifespan but are generally more expensive. Reed relays, these use a sealed glass capsule containing two magnetic reeds. They're highly sensitive and often used in low-power applications. Choosing the right relay depends on the specific requirements of your project. Consider factors like the load current, voltage, switching speed, and environment. Now, let's talk about some common relay applications. Home automation, control lights, fans, and appliances with a microcontroller. Robotics, control motors and actuators. Automotive systems, control various components like fuel pumps, relays, and window lifts. Industrial control systems, control motors, valves, and other industrial equipment. Remember, relays are powerful components, but they also have limitations. They can be relatively slow to switch, and they can generate electrical noise. Also, mechanical relays have a limited lifespan due to wear and tear. So, there you have it. Relays are versatile components that can be used in a wide range of applications. By understanding when and how to use them, you can build more robust and reliable electronic projects. With that said, thanks for watching and until next time.